In this video, I want to solve a polynomial inequality using features of the graph of a polynomial function. We want to solve the problem x minus 2 quantity squared times x plus 5 is less than 0 using features of the graph of f of x equals x minus 2 quantity squared times x plus 5. So let's think about what do we know about the graph of this polynomial function. If we know the degree and leading coefficient, then we know the end behavior of this particular function. Think about what the degree is. Remember that we can look at the product of the leading terms of each factor to figure out what the degree is rather than multiplying that whole expression out. So our first factor, x minus 2 quantity squared, has a leading term of just x inside, so when we square that we would get x squared and something else which we don't care about right now, and then the x plus 5, its leading term is just x. So when we multiply that out we would get an x cubed plus some other terms. So that tells me that the degree of this polynomial is 3, and its leading coefficient is 1. So we have an odd degree with a positive leading coefficient. So remember that odd degree means that the graph has to do opposite things on its ends, and a positive leading coefficient means that it will end going up, right? End in the positive direction. And so we know that it's going to go up to the right and down to the left. The other thing that we know about this are the zeros. We know the zeros come from where that function is equal to 0. And so if we find the zeros, we would set x minus 2 quantity squared times x plus 5 is equal to 0. And therefore our zeros come from the solutions where we get each factor equal to 0. So x minus 2 is equal to 0, or x plus 5 is equal to 0, which gives us x is equal to 2, and x is equal to negative 5. But the other important thing we need to know is the multiplicity of each zero, because that will determine what the graph does at those zeros. Notice that the 2 came from this factor of x minus 2 squared, so the 2 has a multiplicity of 2, and the negative 5 comes from the factor of x plus 5 to the 1, so this has a multiplicity of 1. So recall what that means. An odd multiplicity means that the graph is going to cross the x-axis at that particular 0. An even multiplicity means that the graph is going to bounce off. So let's use that to figure out what the solution of this inequality is, because we're trying to think about graphically what does it mean for a quantity to be less than 0. Well, remember f of x is really just y, and so we're finding what x values have a corresponding y value that is negative, right? The y value being negative is when the graph is below the x-axis. And so we can put all this together to determine that really with just a rough sketch. We know that the zeros are 2 and negative 5. We also know that the graph is going to go down to the left, right? It can't cross the x-axis anywhere else because there's no more zeros, so it's going to go down to the left and it's going to go up to the right. Well, what happens in between there? We know that at negative 5 the graph is going to cross the x-axis, but then it's going to bounce off at the 2, so it means it's going to go up to some point, but then it's going to come back down to be able to bounce off the x-axis at the 2. The only region where the graph is below, if I think about this number line as being the x-axis, the only region where it is below the x-axis is to the left of negative 5. And so my solution set for this inequality would be negative infinity to negative 5. I do need to know what to do at that endpoint. because I'm strictly less than 0, I'm going to use a parentheses. If I was at less than or equal, I would use a bracket. So I had to find the zeros, know their multiplicity, and know the end behavior of the graph. Those pieces tell me where the graph is above or below the x-axis, and from there I can get my solution.